Okay, so we're going to talk about a third form of a quadratic function, which is factored or intercept form. So let's title a new page in your spiral notebook. Hit pause if you need to. And when you're ready, we're going to begin with a quick little review, okay? So we can't really talk about factored form unless we take at least a minute to review or see what factoring is. So given this quadratic equation in standard form, what we can do is we can factor this into two parentheses, right? We spend a lot of time double distributing these parentheses, but we forget we can also go backwards and take our trinomial and split it into the two parentheses, which is what factoring is. So when I factor, I start with the x squared term and I split it into x and x, right? And then I go over here and I look at the constant term, which is negative 12, and I need to split it into its factors. But I want to think about what multiplies to make negative 12, but adds and subtracts to make this middle term right here, negative 4x. And so I'm going to use 6 and 2 because 6 and 2 will multiply to make 12, but if we make this negative 6 plus 2, then when we combine like terms, when we double distribute, it will make this middle term of negative 4x, okay? And then we can also double check and see that a negative 6 and a positive 2 will in fact make a negative 12. So that's kind of the basics of factoring, and that's not really the point of the video, is to factor. So don't worry about it if you feel like you don't remember how to factor. I just want to refresh your memory that we can write we can take a trinomial and write it in factored form. So that's what you're looking at right here is factored form. Well, what we can keep doing here is if we plug 0 in for y, okay, then we can actually take these factors and solve for x. So if two things multiply to make 0, then that means either the first part, x minus 6, needs to equal 0, or the second factor, x plus 2, needs to equal 0. And when we add 6 to both sides, we get x equals 6, and we subtract 2, we see that x equals negative 2. So by solving these factors, what we are doing is determining the roots of the quadratic equation. And so the roots of the equation are going to be 6, 0, and negative 2, 0, which means those are the two x-intercepts, okay? Those are the two places where the graph is going to cross the x-axis. One more little note here about this 0 is the reason here that I plug 0 in for y is because you can see that in every x-intercept, the y-coordinate is always 0. So if you want to go ahead and get your graphing calculator, you can type in x squared minus 4x minus 12, and you will see that the graph of the quadratic passes through 6 and negative 2. So let's go ahead and write out what factored form looks like, or intercept form. It looks like y equals a, and then what you're going to see are these two factors, okay, where the factors or the roots are going to be denoted by p and q. So let's kind of run through this again. The a value again is the one piece that we see in all three forms. So now that we've talked about how to graph the a value, we can use that vertical stretch or shrink in all three forms. So let's just quick review. A is the opening, okay? It's the opening, it's the x-axis reflection, and that would only be if it's negative, but remember it's also the vertical stretch or shrink, okay? The x minus p is going to be the root x equals p, and x minus q is going to end up being the root x equals q. And these are the x-intercepts of the graph, okay? So that's kind of the basics right there of intercept form. Maybe I'll make a little note right here. I feel like I'm missing something. Maybe we should kind of denote that the roots or the x-intercepts, okay, are going to be the x equals p and x equals q. Let's tie all of this together. Let's go ahead and start by graphing a quadratic in factored or intercept form. Y equals negative 2, x plus 1, x minus 3. Okay, we're gonna graph this using 5 points. And again, the kicker is no calculator. We're going to do all of this by hand. All right. Here's what we're going to do to start. You are going to find the roots and the axis of symmetry. Okay. Well, the roots are pretty easy to identify, okay? The roots are going to be, in this factors, x plus 1 and x minus 3. I'm going to kind of highlight this right here. These are where the roots are going to be. So we come over here, and if we think about x plus 1 equaling 0 and x minus 3 equaling 0, then what we see is the roots are -1 and the roots are +3. You don't have to set up this equation and set it equal to 0. In fact, we're going to get to the point where we should be able to look at the factors and know that if we see x plus 1, that really it's the opposite, and that means that x equals -1. So let's go ahead and let's set up our graph right here. And I know you probably don't have graph paper, just kind of do the best you can. And the first root is going to be at -1, and the second root right here is going to be at 3. Well, the axis of symmetry, okay, is going to be in the middle of the roots. So because of that symmetrical aspect to a parabola. And so the middle of the roots right here is going to be x equals 1. And again, that's going to occur in the middle of the roots. So if you want to make a note about that, maybe you could write something about axis of symmetry is in the middle of the roots. Okay, well, now that we know the axis of symmetry, that means that we can find the vertex. And we find the vertex by plugging in x equals 1 because we know the vertex is somewhere on this line. All right, so here's my function, y equals -2. I'm going to plug 1 in for x here, and we'll plug 1 in for x over here. And we get 1 minus 3. Now this is going to be a little bit easier to calculate without a calculator just because we don't we don't have to worry about the squared or necessarily like the order of operations like the other forms. All right, 1 plus 1 is 2, 1 minus 3 is -2. Let's multiply all of this together. -2 times 2 times -2 is going to be a +8. So the vertex is going to be at +1, 1, 2, 3, 4, 5, 6, 7, 8. Right up here at 1, 8 is going to be the vertex. Now, finally, so we've got our two roots. We've got the vertex, that's 3 points. Use the vertical stretch, use A to plot two, oops, kind of skip that there, to plot 2 more points. Okay, and that comes back to that vertical stretch that we talked about, that normally with a parabola, right, normally we would go over 1 unit and down 1, but if the vertical stretch is 2, and we can see obviously that it's -2, which is we can already see here that this parabola is going to open down, so we really didn't have to worry about that too much. But if it normally goes over 1 and down 1 unit, then a vertical stretch of 2 means we're going to go over 1 but go down 2 units, okay, and reflect that point over. So pretty easily here we can get graph this parabola with 5 points without using a calculator. All right, example 2. Given y equals ax times x minus 5, okay, in which quadrants will the vertex be located? All right, just since you're getting all of this from a video and we're trying to do all of this work virtually, I just want to throw in an extra example to make sure that we understand these problems. Hit pause if you need to take more time to copy this down. Okay, so let's take a look at our form here. We don't know what the a value is, right? So we're not really sure if this parabola is going to open up or down. So let's keep that in mind. But I do know here, I'm just going to kind of recopy this. I do know that I can figure out what the roots are. And this usually throws people because they don't they don't see the two parentheses. So initially it doesn't look like it's in factored form, but it is. Because what we could do here is we could rewrite this x as being x minus 0 and x minus 5. But if it's x minus 0, then a lot of times you won't see the parenthesis at all. So this means that the roots, let me scooch this over, the roots right here are going to be at x equals 0, and the root is going to be at x equals 5. So these are the roots. So let's kind of make a picture with this and plot our roots. Oops. Okay, here's 0, 1, 2, 3, 4, 5. Now, as far as the opening goes, that's where we need to consider the two scenarios. If the parabola were to open up, then the vertex would be down here in quadrant 4. Okay, but if the parabola were to open down, then that would make the parabola look something like this, and it would put the vertex over here in quadrant 1. So our answer for this is it could be in quadrant 1 or quadrant 4. And whenever I ask you questions like this, I always want you to show me a picture or show me some kind of reasoning as to why you're giving that answer. All right, last example. Let's write an equation using some given information. Okay, so write a quadratic function. Write a quadratic in standard form. That has roots x equals -2 and x equals 6, such that f of -3 is equal to 27. Okay, finish writing that down. Now when we go into these problems, right, a lot of times it'll say to write a function in standard form, and very rarely do I go straight into standard form and try to figure out what a, b, and c is. Instead, we're going to use factored form or vertex form depending on the information that's given. Well, since we are given the roots, we're going to decide to begin with factored form. So the first thing that we're going to do is we're going to write the equation in factored form. Write equation in factored form. I'm going to add a little extra note based on what I was seeing in class the other day, okay? Don't forget to include a. All right, so y equals, we don't know what the a value is, so rather than leaving it blank or putting a question mark, just write the variable a. So if the root is x equals -2, then that's going to be the factor x plus 2. And if the root is x minus 6, then that's going to be represented by the factor x minus 6. Okay, remember again that there's this element of when we're using parentheses that it's always the opposite. Now, for step number 2, if we want it to pass through the point -327, we need to plug in the given point -327, and you're going to solve for a. So this should seem honestly really pretty familiar and very similar to what we were doing with vertex form. So let's plug in 27 for y equals, we don't know what a is, but we can plug in -3 for the first x and -3 for the second x. And we'll kind of work through this and solve for a without a calculator. So 27 equals a times -1, and -3 minus 6 is -9. 27 equals 9a. Right, when we multiply all of this together. Divide both sides by 9, and we can see that a is equal to 3. So finally here, we just need to kind of remember what it is we're doing. Don't just circle a equals 3 and move on. We have now written this quadratic function in factored form. But it does say to write in standard form, so let's multiply this out and get this equation in standard form. All right, if you want, we're really doing stuff that should be pretty familiar. So if you want to just hit the pause key, you can go ahead and multiply all of this out, kind of scoot to where I get the answer and see if you're doing it right. All right, so I'm going to double distribute first. We get x squared minus 6x plus 2x minus 12. and I'm going to combine like terms, x squared, and we see right here that it's minus 4x. This actually is just like the problem that I started with, isn't it? Y equals 3x squared minus 12x minus 36. All right, so that's a lot of times what we're going to do to get it to standard form is we're not going to go directly into standard form and try to figure out what A, B, and C is. Rather, we use vertex form or factored form and use multiplication to write it into standard form. All right, that's it for now. Your homework is going to be that factored form of quadratics, and I will look forward to seeing those on Schoology.